All right, guys, so let's jump into primes and composites. So the first thing we always want to do when we're dealing with math is let's define particular important vocabulary words. So again, a prime is a number divisible by itself and 1. Divisible by itself and 1. That is it. So therefore, here's some examples. 1 is a prime number. So it's 2, 3, 5, 7. Okay, and then another good one could be 11. Okay, so again, those are just first examples for the first few numbers in our counting numbers, okay? But again, a composite is the opposite. So for a composite number is a number divisible by another number other than 1 in itself. All right, so hopefully, like I said, if you need to pause to be able to write down those definitions, please do so. I'm going to so let's get a couple of examples right below here. These are our notes. So a good example of a composite number could be 4. Because again, 4 divides into 4, so does 2, and so does 1. Okay, also keep in mind, here's just like a little bit of, a composite number is greater than 1. Okay, greater than 1. And in the first example with the prime number, we started at 1 because 1 is prime and so forth. So 4 is a good example. 6. Okay, so 1 times 6 makes 6. So itself and 1 divides into it, but so does 2. And so does 3. Okay, another example could be 8, right? Because 1 divides into 8. 8 divides into 8, but so does 4 and so does 2. All right, so again, the key to primes and composites, to make it very straightforward, to identify them, is definitely make sure you know your multiplication facts. And I'm going to list a couple more. 10 divisible by 1, divisible by 2, divisible by 5, divisible by 10. 12 is another good example. 14, and we can go on and on and on. Okay, so again, the major concept or objective in this particular video is you have to be able to identify what is a prime and what is a composite. Okay, so let's jump into some examples. I'm gonna move the screen there. All right, so let's just say for a moment, somebody gave you the number 15. Okay, so again, this is our practice. We're doing this together. So 15. Is he prime or is he composite? Okay, take a moment to think about that. And then I'm also going to put on here 77. Is he prime or composite? Let's check out 39, 86, 29, 41. I'm going to do a couple more. And let's add on here 40. And let's add on here 83. And 2 more just to get some more practice in. Let's check out 17 and 62. Okay, so again, this is just our little practice. And again, we're trying to identify which one of these are primes and which are composites. Well, the first one that we started with is 15. Okay, so for 15, of course, the answer is composite. And again, he is composite because 1 divides into 15, 15 divides into 15, so does 5, and so does 3. And when I say divides into, that there's a number that divides into that number, leaves no remainder at all. Okay, so he's composite. Look at 77. He's composite because 1 divides into 77, 77 divides into 77, and so does 7, and so does 11. Okay. 39. Let's think about that one for a second. The answer is he is composite. And I know what you're thinking possibly is, well, I don't see 39 on the multiplication table. And that's the thing. I challenge you students and my students that I teach to try to know your multiplications up to 20 times 20. So again, 13 times 3 is 39, and you're used to probably doing 12 times 12, which is 144, and so you don't see past that 12 times 3, which makes 36. So he's there, 13 times 3. All right, 86. Now because this number is even, which means that number ends in a 2, 4, 6, 8, or a 0, which we'll talk about divisibility rules in the videos coming ahead, he's also composite. Because again, 186 goes into him, 2 goes in there, and there are other numbers that go in there as well. All right. 29. Think about that one for a moment. Is he prime or is he composite? And the answer is he is prime. Okay. 41 is also prime. Because again, the only person that goes into 41 and also into 29 is 41 and 1 is 29 and 1. 40 is composite. Because 2 goes in there, 20 goes in there, 10 goes in there, 4 goes into there, leaves no remainder. And 83 is prime. '17 is prime. And then 62, because he ends in a 2, it means he's even, he is composite. Okay? So one of the tricks I want to say to you is when you look at those multiplication tables, think of all the normal numbers that you're used to seeing with multiplication. All right? We've seen 5 times 3 for 15. Okay? We've seen, we don't usually see it on the multiplication, but it's there. 13 times 3 is 39. 11 times 7 is 77. But we've never seen a 41 on the multiplication chart. We haven't seen a 17. We don't see a 29. All right? And so that basically is the end of prime and composites. So what I want you to do now is I'm going to put a few more on the screen. You're going to work on it independently, and then we'll come back together and we'll check and see if you got the right answer. Alright guys, so here they are. These are the problems that I want you to look at and to go ahead and try on your own. So remember, some of them should just jump straight out at you as to which ones are primes and which ones are composites. Take a moment and figure out what the answer is. Alright, so here's the solution. Basically, we know that the first one is a composite. Okay, 48 is a composite. It's a composite because it's divisible by 1, it's divisible by 48, it's divisible by 6, it's divisible by 8, 2, many of them, okay? Even 3 is a number that can divide into 48. 62 is a composite. 31 is a prime. 37 is a prime. 65 is a composite because it's divisible by 5, ends in a 5. 87 is a prime. And then 19 is a prime. All right, so hopefully that went really well for you guys. And it shouldn't be too hard. All right, now as we go ahead and we end this video, you're more than welcome to do more practice problems. But I wanted to go ahead and just one more time just to recap the end of this video. I have told you that again a prime is a number that is divisible by itself and 1. But another shorter way to define it is, let's just say this. A prime has only 2 factors. And again, those factors are 1 and itself. Okay? When we say a composite, these are just shorter definitions, okay? Has more than 2 factors. Has more than 2 factors. So again, someone like we've done before, 15, it has 4 factors. 1 is a factor, 15 is a factor, 5 and 3 is a factor. Now, if you need the definition of a factor, because you've heard me say it all throughout this particular video, a factor is a number that divides into another number and it leaves no remainder. Emphasize that, no remainder. Okay? Alright guys, I hope you enjoyed this video, and that's as simple as it is. Can you identify primes and composites?